የቻናል ቤተሰቦች እንዴት ሰንብታችኋል? ባለፈው ስለ ፕሮግራሚንግ ላንጉዌጅ አይተናል። ፕሮግራሚንግ ምንድነው? ሎው ሌቭል ፕሮግራሚንግ ላንጉዌጅ አይተናል። we have seen machine language and we have seen assembly language. Today we're going to see about high level programming language. So although programming in assembly language is not as much difficult and error prone as that of stringing together a set of ones and zeros in machine language, it's slow. In addition, it is hardware specific as that of the machine language. So this lack of portability between different computers led to the development of high level language. እንግዲህ low level language የምንላቸው ከማሽን ላንጉዌጅ የተሻለ ቢሆንም ነገር ግን still they are hardware specific ናቸው. Plus they lack portability between different computers, or they lack portability between different devices. በተለያየ ዲቫይስ ላይ within the same functioning with the same structure ሊሰሩ አይችሉም ማለት ነው። ስለዚህ የዚህ ሁሉም ዲቫይሶች ላይ የመስራት አለመስራት ችግራቸው ሃይ ሌቭል ላንጉዌጅን ዴቨሎፕ እንድናደርግ አድርጎናል ማለት ነው። The closer the syntax, rules, and mnemonics of programming language could be to natural language. So it should have to be resemble to the natural language. So the less likely it become that the program would be inadvertently introduce error. So ወደ ናቹራል ላንጉዌጅ በተጠጋ ቁጥር የምንጠቀመው ስቴትመንት የምንጠቀመው ኢንስትራክሽን ወደ ናቹራል ላንጉዌጅ የተጠጋ በሄደ ቁጥር the number of the opportunity of creating bugs in our program will going to be decreased. ስለዚህ በፕሮግራማችን ላይ ሊፈጠሩ የሚችሉ ኤረሮች ወይም በግስ የምንላቸው ሊቀንሱ ይችላሉ ማለት ነው። So high-level languages are more English-like, and therefore it make it easier for programmers to think in programming language. So we will going to use English-like words or English-like instruction when we write a program in a high-level programming language. So they also require translation to machine language before execution. So execute ከመደረጋቸው በፊት there is a certain translator in between the source code and the final machine code. So that translation may be a compiler or maybe an interpreter. So compilers translate the entire source code program before execution. Compiler the whole code ነው execute የሚያደርገው, whereas the interpreter will going to do line by line. Interpreter ብንወስድ with a statement ነው የሚወስደው. So if it gets an error, it will not going to translate the rest statement which are under that wrong statement. ስለዚህ whereas the compiler will going to translate the entire source code. So error detection will be done finally, right? But in interpreter, it will going to translate each statement line by line. So when it gets an error in a certain statement, it stops translating the other statements. So there are certain languages, for example, we can use Java, we can use C, C++, Python, C#, and other language can be used here, right? So let's see the advantage of high-level programming language. They are easy to learn, understand, and programs are easy to modify as compared to the low-level language. It's easy to remove errors in programs written in high-level programming language. Programs written in high-level programming language are machine independent. They are portable to different machines with having different operating systems. So as I have told you before, in assembly language or in low-level language, there is a portability problem right there. But rather, right here, they are portable in different machines. So one program can be able to be implemented or can be able to be functioned in a different device without vendor dependent, right? So high-level programming have better documentation as compared to the low-level programming language. So let's see the disadvantage of high-level programming language with respect to the low-level programming language. They are slower in program execution. Slow ናቸው። ለምንድን ነው slow የሚሆነው? The computer will not going to directly understand the code we write with high-level language. So there it should have to be translated to the computer understandable format, which is the machine language. So that translation is going to slower the execution time of our program. It takes additional translation time to translate the source code to machine code. High-level programs are comparatively slower than the low-level programs. Compared to low-level programs, they are generally less memory efficient. cannot communicate directly with the hardware, because the hardware or the computer will going to understand directly only the number of ones and zeros. So it should have to pass certain stage so as to be executed. So high-level language can be grouped into categories based on execution model, or we can classify them as a compile language or a interpreter language ብለን ልንከፍላቸው እንችላለን። እዚህ ጋር ኤግዚኪዩሽን ሞዴል ኦር ትራንስሌሽን ከሚጠቀሙት ትራንስሌተር አንጻር ለሁለት ልንከፍላቸው እንችላለን። አንደኛው we can call them compile language, the other we can call them interpreter language. So interpreter language will going to use an interpreter as a translator, whereas the compile language is going to use a compiler as an interpreter. So the other is we can classify high-level language with several other categories based on a programming paradigm or the style we program. We can classify high-level programming language into structured language, procedural language, and object-oriented language. So let's see about translators. Computers only understand machine code or binary, but on the other hand, programmers prefer to use a variety of high and low-level programming language. So to get rid of this issue, the high-level and the low-level programming code or source code needs to pass through a translator. So translator የምንላቸው እነኚህ በሃይ ሌቨል ኦር እንግሊሽ ላይክ ስትራክቸር የተጻፉ ፕሮግራሞችን ወደ ማሽን አንደርስታንዳብል ፎርማት ኦር ወደ ባይነሪ የሚቀይሩልን እነኚህ translator ብለን እንጠራቸዋለን ማለት ነው። Good. So a translator converts the source code into machine code, or we can call them an object code. So we don't have different types of translator. We don't have a compiler, we don't have an interpreter, we don't have an assembler. So right here, we do have source code. We do have a source code. It may be a C++ program, or it may be Java program, or it may be any other high-level Java high-level program. So in between, we do have a translator. So that translator will going to convert the written source code into their binary code. So finally, the computer will going to understand this one, right? We're going to understand this one. So every written high-level language is going to be converted to its corresponding machine code, or we can call them a binary code. So this is all about how the translator works, or how a high-level program will be executed. So let's see program paradigm. So a program paradigm is a style or a way of programming. So it's a way of doing something, not complicating actually. So on the basis of design paradigm, the high-level programming can be categorized into the point type, procedural, logic-oriented, and the object-oriented programming. So let's see the procedural, or can call them function-oriented programming. In this language, a program is written as a sequence of procedures. So its procedure contains series of instructions for performing a specific task. So its procedure can be called by another procedure during the program. So we don't have a sequence of procedures. They are written sequentially. So each procedure can call another procedure. So it is going to perform certain tasks calling another procedure in the program. So in this type of program paradigm, a code once written in the form of a procedure can be used any number of times in the program by only specifying the corresponding procedure. So we can be able to call that procedure once we have a certain sequential procedure. So we can invoke, or we can call that procedure with using the procedure. So this procedural-oriented language allows us data to move freely around the system only using the procedure. So there are certain examples of procedural-oriented language. We can call Fortran, P, Basic, and others are under this procedural or function-oriented programming paradigm. Let's see logic-oriented programming. This language are logic-oriented programming language are use logic programming paradigm as a design approach for solving various computational problems. So in programming, we don't have a predicate logic, which is the nature of the problem by defining relationship between rules and facts, and based on those rules and facts, we're going to conclude something, right? So Prolog is the best example of the logic-oriented programming language, so it allows programs to specify a set of rules and facts about the problem domain and then use those rules and facts to automatically infer solution to problems. So such type of programming is mainly to develop logic-based artificial intelligence develop ለማድረግ የምንጠቀማቸው ላንጉጆች እነዚህ ሎጂክ ኦሪየንትድ እንላቸዋለን። ለምሳሌ እንዴት እንወስድ እንችላለን? You can take, for example, we do have x አለን, we do have y. Let's take x is a sister of y. X is a sister of y. Sister of y አለን ብንወስዱ ለምሳሌ ይሄ ምንድነው? ፋክት ነው ማለት x sister of y ፋክት ነው። And also x is father of z. Z knows x is father of z. So x is father of z. So let's take y has a child h. H የሚባል child አለን ለምሳሌ y. So based on this information, we can conclude that the relationship between z and h. እዚህ ጋር ምንድነው የምናደርገው? we have facts. ለምሳሌ የመጀመሪያው ፋክት x is sister of y አንደኛው ፋክት ነው። ሁለተኛው ፋክት ደግሞ ምንድነው? x is father of z. x is father of z. So based on this information ማድረግ እንችላለን። ፋሚሊ ሪሌሽን ነው ብንወስድ ለምሳሌ h and z are cousins ብለን እንወስድ እንችላለን ማለት cousins ብለን እንወስድ እንችላለን። ሶ እነዚህ ሎጂክ ቤዝ ኤአይዎችን ዴቨሎፕ ለማድረግ የምንጠቀምባቸው ፕሮግራሚንግ ላንጉጆች ናቸው። ሌላው ኦብጀክት ኦሪየንትድ ፕሮግራሚንግ የምንለው ነው። This language object-oriented programming paradigm as design approach for solving a given problem. ቅድም እንግዲህ procedural ላይ ያየነው ምንድን ነው? Data እና behavior, they are separated in the procedural programming, whereas in the object-oriented programming, they are bundled together with a single entity which is called an object. ስለዚህ ይሄኛው ምንድን ነው? We don't have a number of objects that can be able to bundle the data or the fields or the behaviors or function intellectual. So within that single object, you can be able to bundle data in function. So procedural oriented or function oriented object oriented data and functions are bundled together. They are not separate, right? So they are bundled together with a single entity. It's called an object. So you're going to have certain blueprint or a certain class. So from that class, we can be able to create any number of objects. So that object is going to access the data and the behaviors of the class. So this is all about the object-oriented language. Next, we're going to see problem-solving techniques. So if you get this video helpful, don't forget to like, share, and subscribe, and hit the bell icon so you will going to be notified when I was going to post new concepts up on this programming session. Thank you for your attention.